The reconnaissance photographs lay on the desk in silence. An intelligence officer at Luftwaffe headquarters studied them for the third time that morning. The images showed something that appeared impossible. April 1944. Berlin, Germany. The photographs had been taken by high-altitude reconnaissance flights over Texas. They showed a factory in Grand Prairie, a place most German officers had never heard of. The facility itself wasn't remarkable. Standard industrial construction. Concrete and steel. What caught attention were the parking lots. They were always full. Morning photographs showed thousands of vehicles. Afternoon surveillance showed thousands more. Evening passes revealed the lots still packed with automobiles. Someone had made an error in the reconnaissance schedule. That was the logical explanation, except there had been no error. The facility operated continuously. 3 separate shifts of workers, 8 hours each. 24 hours of production every single day. The officer closed the folder. He understood what the photographs meant. He simply didn't believe it was sustainable. German aviation experts had built their entire war strategy on assumptions about industrial capacity. Those assumptions were grounded in European experience, in German production methods, in what was considered possible within the boundaries of manufacturing logic and workforce management. A fighter aircraft required approximately 9,000 man-hours to construct. That figure represented the German standard for the Bf-109. It was efficient, streamlined, the result of years of refinement. German factories operated on carefully structured schedules. Workers arrived in the morning. Production occurred during daylight hours when quality could be monitored. Precision work required visibility, concentration, the kind of attention that deteriorated during extended shifts. Night production existed, but it was limited. The logic was sound. Aircraft manufacturing involved thousands of complex operations, riveting that required exact placement, wiring systems that demanded perfect installation, engine assemblies where a single misaligned component could prove catastrophic. This work could not be rushed. It could not be delegated to exhausted workers operating under artificial lighting in the middle of the night. Hermann Göring had laughed when he first heard reports of American production targets. 50,000 aircraft per year. The Americans had announced this figure as though it were achievable, as though they could simply decide to build planes the way one decides to increase production of automobiles or tractors. Göring, himself a fighter ace from the previous war, understood aviation. He knew the complexity involved, the precision required, the skilled labor necessary. 50,000 aircraft per year was propaganda. It had to be. The mathematics alone proved it impossible. But the reconnaissance photographs from Grand Prairie told a different story. The initial analysis focused on workforce size. Intelligence estimates suggested the North American Aviation Facility in Grand Prairie employed approximately 15,000 workers at any given time. That number aligned with German expectations for a large production facility. 15,000 workers operating on a standard schedule could produce a respectable number of aircraft. Perhaps 300 per month if the operation ran efficiently. But the photographs revealed something the numbers didn't explain. The facility never went dark. Surveillance flights conducted at different hours showed continuous activity. Lights burning through the night, smoke from industrial processes rising at dawn, noon, and midnight. The initial explanation was maintenance. Perhaps the Americans were conducting repairs during off hours, equipment servicing, facility upkeep. This made sense. It was logical, except the parking lots remained full. A maintenance crew would number in the hundreds, not thousands. The number of vehicles visible in the night photographs suggested a workforce equivalent to daytime operations. German analysts began calculating different scenarios. If the Americans were operating 2 shifts instead of 1, production capacity would double. That would be unusual but not impossible. Some German facilities had experimented with extended hours during peak production periods. The numbers still didn't reconcile with the intelligence coming from other sources. Captured American airmen were interviewed. Their answers proved unsettling. They spoke casually about production figures that German officers initially dismissed as exaggeration or misinformation. 500 aircraft per month from a single facility, 700 during peak periods. These numbers seemed designed to boost morale rather than reflect reality. Then more photographs arrived. These images showed the flight line at Grand Prairie. Rows of completed P-51 Mustang fighters, not dozens, hundreds. They sat wing to wing awaiting delivery flights. One series of photographs, taken over consecutive days, showed the rate at which these rows emptied and refilled. Aircraft disappeared as quickly as they could be produced. The mathematics became impossible to ignore. If the Americans were truly producing at the rates being observed, they weren't operating 2 shifts. They were operating 3. German production experts understood the theory of continuous manufacturing. It existed in industries where the process was simple, where raw materials entered one end of a factory and finished products emerged from the other with minimal human intervention. Steel mills operated continuously. So did some chemical plants. But aircraft production was different. A fighter plane consisted of thousands of individual components. Each required skilled labor. Each demanded attention and precision. The assembly process involved coordination between dozens of different specialties. You couldn't simply add more workers and expect proportional increases in output. Overcrowding created inefficiency. Workers interfered with each other. Quality control became harder to maintain. Error rates increased. The German aviation industry had studied these problems extensively. They had determined that there were optimal workforce sizes for given facility footprints. Beyond those thresholds, adding more workers produced diminishing returns. The Americans appeared to be ignoring these limitations entirely. Intelligence reports indicated that at peak production in April 1944, the Grand Prairie facility employed more than 38,000 people. Not 15,000, not 20,000. 38,500, all working in the same facility, operating 3 complete shifts around the clock. The day shift arrived at dawn. 8 hours later, they departed as the evening shift arrived. 8 hours after that, the night shift took over. When the night shift finished, the day shift was returning. The factory never stopped. Not for maintenance, not for retooling, not for rest. German analysts tried to understand how this was physically possible. The facility in Grand Prairie occupied significant space, but it wasn't dramatically larger than comparable German installations. How did you fit 38,000 people into a workspace designed for a fraction of that number? The answer lay in something German facilities had never seriously considered. The Americans had built the entire factory without windows. This seemed like a minor detail, but it was fundamental to the operation. Without windows, there was no distinction between day and night inside the facility. The building was completely climate-controlled, artificially lit. Every corner could be utilized for production regardless of the hour. Workers on the night shift experienced the same conditions as those on the day shift. Lighting remained constant. Temperature stayed regulated. The environment inside the factory bore no relationship to the world outside. This allowed true 24-hour production. It also revealed something deeper about American industrial philosophy. The Germans built factories that adapted to human rhythms. Work occurred during daylight because that's when humans naturally worked. Factories had windows because people needed to see outside. Shifts ended so workers could return to normal life. The Americans had inverted this relationship. They built factories that ignored human rhythms entirely. The work defined the schedule. The mission determined the hours. If victory required 24-hour production, you built facilities that enabled it. You removed the windows. The impact of continuous production extended beyond simple mathematics. German intelligence had calculated that if the Grand Prairie facility alone was producing 500 to 700 P-51 Mustangs per month, and if other American facilities were operating on similar schedules, the total monthly production of fighter aircraft in the United States might exceed 3,000 units. 3,000 fighters per month meant 36,000 per year. From fighters alone. That didn't include bombers, transports, trainers, or reconnaissance aircraft. The total production figure for American aviation might approach 100,000 aircraft annually. These numbers were reported up the chain of command. They were met with skepticism, then denial, then quiet acceptance. Albert Speer, who had been appointed Reich Minister of Armaments and War Production in 1942, understood the implications immediately. Germany was producing excellent aircraft. The Bf-109 remained competitive. The FW-190 was formidable. German engineering was sound, perhaps superior in certain technical aspects, but engineering excellence couldn't overcome mathematical reality. If the Americans were building 10 aircraft for every one Germany produced, technical superiority became irrelevant. The Luftwaffe couldn't achieve air superiority when outnumbered 10 to 1. Individual German pilots might be better trained. German aircraft might have specific performance advantages. None of it mattered against overwhelming numerical odds. Speer initiated studies on whether Germany could match American production rates. The answer was immediate and unambiguous. Germany lacked the raw materials, the facility space, the workforce, the geographic security. Even if all these obstacles could be overcome, the time required to build new facilities and train new workers meant any production increase would come far too late. The reconnaissance photographs from Grand Prairie appeared in briefings with increasing frequency. They became a symbol of something German leadership had failed to fully appreciate. American industrial capacity wasn't simply larger than Germany's. It operated on fundamentally different principles. The P-51 Mustang being produced at Grand Prairie was itself a symbol of this difference. The aircraft had been designed and put into production in under a year, from initial concept to operational deployment. American engineers had created an airframe, tested it, refined it, and begun mass production faster than German engineers could complete a single design cycle. This wasn't because American engineers were more brilliant. German aviation designers were among the best in the world. It was because the American system was designed for speed. Decisions that took months in Germany took weeks in America. Design changes that required committee approvals and ministerial sign-offs in Berlin happened through direct conversations between engineers and production managers in California and Texas. The P-51 itself embodied American manufacturing philosophy. It was designed to be mass-produced. Components were standardized wherever possible. Assembly techniques prioritized speed without sacrificing quality. The aircraft used an existing British engine, the Rolls-Royce Merlin, rather than waiting for a new American design. This pragmatism horrified German engineers who encountered it. A fighter aircraft should be optimized from the ground up. Using an off-the-shelf engine seemed like a compromise, a shortcut. But the P-51 with its borrowed British engine was faster, had longer range, and arrived in operational service years before comparable German designs. The production statistics told the story. In 1943, the man-hours required to produce a single P-51 at the North American Aviation plant stood at approximately 12,000 hours per aircraft. By 1945, that figure had dropped to just over 2,000 hours. The aircraft hadn't been simplified. Quality hadn't declined. The reduction came entirely from refined production techniques, from learning, from systematic improvement. German production of the Bf-109 showed similar improvements over time, but the baseline efficiency of American production had already surpassed German peak performance, and the Americans kept improving. There were structural reasons why Germany could not match American production methods even if given unlimited time and resources. Geography provided the foundation of American advantage. The Grand Prairie facility operated without fear of bombing. No air raid sirens interrupted production. No workers spent nights in shelters. No production lines were destroyed and had to be rebuilt. German factories faced constant threat from Allied bombing. Even facilities that weren't hit directly lost production time to air raid warnings. Workers evacuated to shelters. Production stopped, sometimes for hours. This disruption was impossible to quantify in simple statistics, but its cumulative effect was devastating. A factory that stops production 3 times per week for 2 hours each time loses 126 hours per month. That's more than 5 full days of production. Every month, German factories near major cities experienced far more frequent disruptions. The Americans faced no such constraint. Workers in Grand Prairie arrived for their shifts knowing they would work uninterrupted for 8 hours. No sirens, no bombs, no terror. This psychological difference mattered as much as the physical one. Material supply represented another insurmountable advantage. American factories received steady streams of aluminum, steel, rubber, and other critical materials. Suppliers operated without fear of interdiction. Transportation networks remained intact. German facilities experienced constant material shortages, not because Germany lacked resources entirely, but because those resources were increasingly difficult to transport. Rail lines were bombed, trucks were destroyed, materials that existed couldn't reach the factories that needed them. American production planners could schedule production months in advance with confidence that materials would arrive as needed. German planners had to constantly adjust schedules based on what materials were actually available on any given week. This created cascading inefficiencies. Partially completed aircraft sat in factories waiting for specific components. Workers who could be assembling planes instead performed maintenance or make work tasks. Production capacity existed but couldn't be utilized. Then there was the question of workforce. The 38,000 workers at Grand Prairie were fed, housed, and paid reliably. German workers increasingly struggled with food shortages, housing destroyed by bombing, and uncertainty about their family's safety. A hungry, worried worker is not an efficient worker. None of these factors were within German control to fix. By late 1944, the reality of American production capacity had moved from intelligence assessment to battlefield experience. Luftwaffe pilots encountered P-51s in overwhelming numbers. Skilled German pilots shot down American fighters regularly, but for every American plane destroyed, 2 more appeared, then 4, then 10. The mathematics were brutally simple. Germany could not produce pilots as fast as America produced aircraft. Even if German training could match American output, which it couldn't, there weren't enough airfields, fuel, or time to maintain operational parity. The P-51s from Grand Prairie appeared over Germany escorting bomber formations. These fighters had the range to accompany American bombers all the way to targets deep in German territory and back. Prior to the P-51's deployment, German fighters could attack Allied bombers with relative impunity once other escort fighters reached their range limits and turned back. The Mustang eliminated that advantage. Now, German fighters faced opposition throughout the entire mission. American bombers reached their targets. German industrial capacity, already strained, deteriorated further under sustained attack. The cycle reinforced itself. American production increased. German production declined. The gap widened not arithmetically but exponentially. By early 1945, the United States was producing more combat aircraft in a single month than Germany produced in an entire year. The reconnaissance photographs from Grand Prairie kept arriving in Berlin. They showed the same thing they had shown a year earlier: parking lots full of vehicles, factory lights burning at all hours, rows of completed fighters waiting for delivery. The only thing that changed was the number of aircraft in those rows. It kept growing. The story of Grand Prairie was not fundamentally about engineering or tactics or strategy. It was about systems. The Germans built excellent aircraft using skilled craftsmen and sound engineering principles. They fought bravely and effectively. But they were operating within a system that had limits. The Americans built a system designed to exceed limits. 24-hour production wasn't about working people harder. It was about removing the assumption that work should align with daylight hours. Continuous production wasn't about eliminating rest. 3 shifts meant workers still worked 8 hours and rested 16. It was about eliminating the assumption that factories should rest. The distinction mattered because it revealed different philosophies about what was possible. German production experts believed there were natural limits to manufacturing capacity: optimal workforce sizes, diminishing returns. American production experts believed limits were design problems to be solved. If you needed more output, you built larger facilities. If you needed continuous production, you removed the windows and added climate control. If you needed more workers, you built housing developments and constructed entire communities. The scale of American ambition would have seemed absurd to European planners accustomed to incremental improvement. The Americans approached industrial production the way they approached everything else: as a problem with a solution, as a challenge with no inherent upper boundary. They asked what would be required to build 700 aircraft per month, then they built the systems to do it. When they discovered they could do it, they asked how to build more. The war was decided by many factors. Battles mattered, tactics mattered, leadership and courage and sacrifice all mattered, but underneath all of it was simple arithmetic. The side that could replace losses faster than the other could inflict them would win. The photographs from Grand Prairie showed who that side would be. World War II ended with production figures that still seem impossible. From 1941 to 1945, the United States produced approximately 300,000 military aircraft. 300,000. The Grand Prairie facility alone produced more than 18,000 planes during the same period, including more than 9,000 P-51 Mustangs. German production over the same period totaled approximately 120,000 aircraft. These numbers represented more than industrial capacity. They represented the difference between systems that accepted limits and systems that refused to. After the war, German aviation experts who visited American factories tried to understand what they had witnessed. Many focused on the technical aspects: the windowless construction, the climate control, the assembly line innovations. But the real difference wasn't technical, it was philosophical. The Americans had decided victory required a certain level of production, and they built whatever was necessary to achieve it. They didn't ask whether it was practical or sustainable or aligned with traditional manufacturing wisdom. They asked what was required, then they did it. The lights at Grand Prairie burned 24 hours a day, 3 shifts, without interruption. They stayed lit until victory was assured. Then they turned them off. The facility that had employed 38,000 people stood empty. The parking lots that had been full around the clock sat vacant. The war was over. The aircraft stopped rolling off the production lines not because the system couldn't continue, but because it no longer needed to. That might be the most remarkable thing about American wartime production. It wasn't that it seemed impossible. It was that once it was no longer necessary, it stopped as quickly as it had started. The capacity existed. The system worked. The machinery stood ready. It simply wasn't required anymore. When you visit Grand Prairie today, the aviation industry still exists there. Different companies, different aircraft, different era, but the legacy remains. The idea that production capacity is limited only by imagination and will. That continuous operation is possible if you design systems to enable it. That seemingly impossible production targets become routine once you remove the assumption that they can't be achieved. German aviation experts who studied the Grand Prairie facility came away stunned not by American technology, which was often less sophisticated than their own, but by American audacity, the willingness to attempt things that conventional wisdom said were impossible, the confidence to build factories without windows and staff them with 3 shifts operating around the clock, the certainty that if the mission required 700 aircraft per month, you didn't debate whether it was achievable. You built the systems to make it happen. That mindset built more than aircraft. It built victory. Consider this. If Germany had possessed the industrial capacity to match American production, would the outcome of the war have been different? Or was American production itself the result of deeper systemic advantages that couldn't be replicated regardless of resources? This video is based on historical records, expert analysis, and documented sources. Some interpretations are simplified for storytelling clarity.